Vectors in a plane is simply a reference to two-dimensional vectors, also called R2. Notice in the official definition of a vector is composed of a magnitude and a direction. Notice there's no mention of position. When we draw vectors, we draw lines where the length of the line represents the magnitude. So it's obviously important that we get lengths proper. And there's an arrow representing direction. Obviously, that will be incorrect without the arrow in the right direction. Now here I've drawn a coordinate system, and I've put a couple of points on there labeled B and D, and we have a vector that obviously with the arrow on the end closest to D means it's going from B to D. Now we designate that by putting BD with an arrow over the top of it going from B to D. Now the point B is 1, 3, the point D is 5, 4, so the vector that we're talking about, BD, would be the vector 4, 1 with the angle brackets on it. Now in ours and many textbooks, vectors are shown with bold-faced letters. There are times, however, when you'll see a book or something in writing that does not have a bold letter. Instead, it'll be a normal cursive type letter with an arrow over the top, maybe even an arrow with half a point on it to indicate that it's a vector. Also, the textbook we use, and many others in fact, use the angle bracket notation for vectors in component form. Some textbooks will use brackets for vectors. In fact, you'll see that in Maple, when we get to using that, that's their symbol. And in fact, some use column vectors instead of row vectors. Now again, let me point out that the position is immaterial, and so the vector going from the origin to the point 4, 1 is the same vector as the vector BD. Now the magnitude of a vector also goes by the name norm. You'll find that on your calculator when you go try finding the magnitude of a vector. And to find the magnitude of the vector, we simply take the x distance, the y distance, and form the right triangle and use the Pythagorean theorem. The symbol for magnitude, as you can see, is the double bars on either side. So let's try some vector operations. Now here we have the red vector designated U and the blue vector designated V, both drawn from the origin with the tails of the two vectors together at the origin. And we're going to construct a parallelogram. You can see I've got this color coded for you. And the vector that goes from the origin to the points diagonally across the parallelogram is the vector U plus V. We sometimes call that the parallelogram property. Now here I've drawn the vector v minus u. Notice it likewise goes from one corner of the parallelogram to the other. Specifically, the vector v minus u goes from the tip of u, the terminal point of u, to the tip of v, the terminal point of v. So make sure you recognize the order, because the vector u minus v would go in the opposite. Now here I've taken the vector u, the red vector, and duplicated it. In other words, there are two of them. Two u's. Now 2u is nothing more than doubling each component. So if we double the x component and double the y component, we get the vector 2 times u. Now the vector v is the one that's going from the origin to the point 4, 1. And so the vector that goes directly opposite of that and is the same length would be the negative of that. Now the negative of that would simply be the negative of the 4 and the negative of the 1. Same length, opposite direction. Now unit vectors are very important throughout math and science and engineering. So let's make sure we catch on to the use of unit vector. The term unit vector simply means a vector with a magnitude of 1. Many times in dealing with vectors, we're interested in the direction only and not the magnitude. So oftentimes we will form a unit vector so that we can just have direction and not magnitude. Also, unit vectors are used for building other vectors of known quantities. So the two unit vectors that we're going to be starting with are the vector 1, 0 and the vector 0, 1. Now, you can tell by looking that those are 1 unit long. Now the vector negative 4, 3 is not 1 unit long. If you did the magnitude of that, the norm of that, you'd see that the magnitude is a 5. Well, to form the unit vector, we simply take the vector and take the x component and divide by the magnitude, and that gives us the x component of the unit vector. And the same thing with the y components. Now the vector 1, 0 is referred to by the bold-faced letter I. The vector 0, 1, the one that points up the y-axis, is referred to by the bold letter J. And so we have a way of representing vectors, such as this one, by using a linear combination of the I and the J. Notice that for the vector 5, 3, we've got 5 I vectors, 3 J vectors added together. So the vector 5, 3 and the vector 5i plus 3j are two names for the same vector. Now here's a list of properties of vectors that you might want to print out and look over. Let me remind you that the bold letters represent vectors. The not bold letters and numbers just represent scalar quantities or numbers. And so let me explain just a few of these and you can look them over. The first two, the commutative and the associative, you've seen before back in beginning math. That just means that when you're dealing with vectors, order is not important in adding vectors. Now the next one simply says, notice the 0 is a bold 0. That is called the 0 vector. For example, the vector 0, 0. would be the 0 vector. The vector with every component equal to 0. And of course you can see that's called the identity. Now when you look at these, notice again the R and the S are numbers. And again, this is simply saying, just like up above, when you're multiplying using scalar quantities, it doesn't matter which you do first. You also have a distributive property using scalar quantities. Now again, in the last two, notice the number and the vector. You're multiplying the vector u by a 1, which means you just come out with the vector u. You're multiplying the vector by the number 0, and you come out with the 0 vector, not the number 0.